where we left off on Thursday that we didn't get done. Okay, our goal today. Finish section 1.5. I think we can do it. Yes, and stuff still to work on. We did get all the way up to, well, first of all, we're working on graphs, right? We're working on graphs. So, have I told you guys before that domain is how far left and how far right? Mm-hmm. Yes. But technically, we weren't looking at graphs before. We were looking at functions and equations. So it's a little bit different. Range, I've told you how far up and down. Well, I would say down and up. So what was, just look right here. What was something new we learned on Thursday? Do you remember what these are called? They had brackets or parentheses, commas. The little e, that means is an element of. But what was this notation?
Interval notation.
Good. That was new. Interval notation. So this is not an ordered pair. This is a beginning and an ending of an interval on a graph, of a horizontal interval. Beginning and an ending of a vertical interval, because it has y's and stuff. So in just a second, after I talk about the graphing calculator quiz, as I finish passing these out, you guys are going to have an example where I give you a sample graph. And I'm asking you to look at that sample graph and try to answer, how would you fill in this for domain? How would you fill in this for range? And then there are a couple extra questions just to see if you can understand. I gave you guys back the graphing calculator quiz on Thursday. And some of you were like, this grade is not what I wanted, right? Okay. Do you have your handbook that has all the information, all the different ways of using your calculator to solve problems? Yes. I'm going to finish passing out your worksheets as well. Okay. Worksheet number 1, you were doing things like values, zeros, intersections. You did not have to do maximums or minimums on calculator worksheet number 1. On calculator worksheet number 2, you guys were doing things like, that's not worksheet number 2. Those all got passed out. Oh, no, they didn't. The things with the tables, where you were doing regressions and you were solving and you were plugging in. But there also was, I think on number 4 and maybe on a couple more, you also had to find like a maximum. Maybe you had to find a minimum. I think it was just a maximum. Okay. Between the handbook and the worksheets, my hope is that you can take this quiz, go to the handbook and the worksheets and say, what did I do wrong? Now, if some of you guys have something like, ready? Look up here. If you have a blank, if I drew in my blue pen, that's what I graded in. If I drew a blank with an X or with a question mark, that means you're missing an answer. Does that make sense? So some of you, for instance, on number 1 of the quiz, you wrote or you got 2.5, but there were 2 answers. There was 2.5 and 3.5 on the first zeros for F. So if you got one of them and not the other, I'm like, oh, you forgot to look. There were 2 zeros. Okay, so if there's a blank with an X or a question mark, you're missing a whole answer. If there's something with a slash through it, it was an incorrect answer. If I wrote something like rounding, I think I wrote rounding, I would have taken off like a half point. That means you didn't correctly round the 3 decimal places. So for instance, I think there was one that was like 2.9999. How does that round? 3.000 or just 3. 2.9999, it rounds all up to 3. Some of you guys missed that. That's an example. Or some of you put 2 decimal places instead of 3. Or you were a little off, but I could tell it was just because of rounding. But if I said the word off, that means something wasn't right. Maybe when you did your max, you didn't go to the left enough and to the right enough, so you kind of got close. Or maybe you just traced and like, oh, that looks good, but you never actually used the feature, so it wasn't exact. If I wrote off, something is off. Something, you seem to be kind of close, but for some reason your decimals were, it wasn't just rounding. What else went wrong? Oh, if you just didn't do a sketch and I put a big question mark, you just need to draw the sketch. I'm not sure what else really would have gone wrong. Those are the main things. So, what are you guys supposed to be doing with these quizzes? Correcting them in some other color other than blue, which is what I wrote in, or black-gray, which is what the question was written in, right? You're supposed to be correcting in a different color pen. If you're like, this is just messy, could you do it on a different piece of paper and staple it? That's okay. If you want to totally redo the whole quiz, that's fine. But the long story short is you are trying to get it right. Can you work with someone else in the class? Maybe they got some right answers and you didn't get them? Yes, you can work with them. But my question to you is, are you understanding as you're working with them? Are you asking questions? Is there discussion, or is it just like, that's the right answer? Sweet. Did you learn anything if you do that? No. You need to learn because we're going to be using our graphing calculator, and I'm trying to get you points back, but what's the point of giving you points for someone else's answer? That doesn't help you. That doesn't help your grade. That doesn't help your understanding. So please, please, please take some time to correct this quiz. I'm not going to collect the corrections from you today. If you have them done today, that's perfect. But I'm going to go ahead and we have a homework due tomorrow. And then we have a review for, let's look at our calendar really quickly. You guys notice, remember we're splitting chapter 1 in half? And we are finishing 1.5 today. I was warning you last week that we had a quest to come in. That's where we're pausing. So we're going to go ahead and have a review tomorrow, 1.1 to 1.5. And we're having a quest test, well, the test on Thursday on 1.1 to 1.5. Okay, so we've gotten up through halfway today. Homework is due tomorrow. You guys hopefully over the weekend got caught up on homework. We do have a test on Thursday. Let's have the graphing calculator corrections due on Friday. Why is Friday a great time for it to be due? What's your homework on a test day? Just rest from Precalc. But what's it going to be this time? Finish your corrections on your graphing calculator course. Does that sound good? Okay, I'll go ahead and get your calendar updated today. I wanted to make sure that you guys saw that because right now there would be no homework due this day. We would just start section 1.6. We are going to do that, but I'm going to go ahead and make the homework this night. Finishing any other quiz corrections, we'll turn that in on Friday. Okay? I'm going to finish passing these out. Any quick questions about the graphing calculator corrections? If you're able to get the correct answer, another good reason to talk with others in any of the pre-calc classes, if you're able to get the correct answer and understand it, which hopefully that's how you get it, you will get half points back on this quiz. Sound good? What's half points back mean? If you got a 0, you can get 10 out of 20. If you got a 10, you can get 15 out of 20. If you got an 18, you can get 19 out of 20. You can get half the points you missed back. Does that make sense? That wouldn't be too bad for us to do, especially since we don't have many grades in our category yet, right? The test on Thursday will be a huge decider as well. So let's go ahead and get back into our notes. Let's finish up section 1.5 so that we have time tomorrow to review as much as possible. So I want you guys to go ahead and get the graph, draw it in your notes. It's a weird squiggly. What's going on? How do you draw this graph? I don't know, I made it up. It's like a swoop, but there's a few scoops. I want you guys to, I know, but when you sketch graphs, some of you are horrible sketching graphs. You make sure you get the points. Get the points. If you get the representative points, the important points, can't you just swoop and there it is, right? Exactly. Just get the important points drawn. You don't even have to label stuff. Just get a graph and get -1, 1, 0, 3, 2, -3, and 5, 2 drawn. The last one being a hole. Don't even worry about the labels. Just get me the graph and then see what you can answer. Use your notes. Look and see what they look like. We might have gotten a graph on Friday or Thursday, but I don't think you actually had time to try to answer them. So look at what domain should look like. Look at what range should look like. And do you guys know how to fill these in? Coco dropped and Jacob also. You guys, please, let me get you points back on the graphing calculator, please. can come by any day after school. I am here. I'm available. If after school doesn't work, tomorrow morning is when I have coffee and donuts for the Calc kids. You can sneak in. I'll be at my desk. Just available for questions. If tomorrow morning after school doesn't work, come find me during lunchtime. Hi kids, you have had a little bit of time. Normally I would love to give you a little bit longer, but some of you already had this drawn in your notes anyway, so you've already had all the time to think about it. And we do want to get through this section really well today so that you're more than prepared to finish that homework in section 1.5. There is a test review homework as well for sections 1.1 to 1.5, just kind of putting it all together. It mostly goes in order of the sections, some from 1, some from 2, some from 3. You guys should see it on your homework sheet, because the homework sheet has 1.1 through 1.5, and there's also a review section. So if for any reason you do finish a little early tonight and you want to get going on setting on your test, you can go ahead and start that review early. That's pretty much what we'll be working on together in class tomorrow. Sound good? What question in your notes are you supposed to ask yourself when thinking domain?
How far?
Left to right. Okay, so how far? What's the left end x value? What's the left endpoint for x end? -1. Think about on the x-axis horizontal. What's the farthest left it goes? Good, -1. Bracket or a parenthesis? What do you think?
Bracket.
Why? It's a closed circle, so it does hit at -1. Good. How far right does it go? Go along the x-axis. How far right does this graph extend? Good. All the way to 5, but open or closed? Open circle, so parenthesis or bracket? Parenthesis. How many of you guys got that? Give me a quick thumbs up. Okay. Let's go over. How far left to how far right? Can we answer range real quick before we go to the middle ones? Range. What question do we ask ourselves? First, it's how low to how high. But technically, what comes first? Not how up, how low. Low, how down. The lowest first. So how low does this graph go on the y-axis? Going down. How low does it go? Closed or open? Good. There's it closed out at -3. How high does it go?
3.
Good. Closed or open at 3? Good. Did anybody get confused about the whole though? Did you get confused by this guy? No. Maybe not. Never mind. Good. The long story short, if you did get confused by this guy, some are like, but wait, we have to take out 2. No, we don't. Does it hit 2 somewhere else? Yes, it does hit all the values from -3 all the way up to 3, and some of them it actually hits even more than once. This one doesn't actually cause us any problem for the range. It does go all the way from -3 to 3. How many guys got the range right? Quick little thumbs up. Good. Okay. Those of you guys that missed, do you have any questions you can ask? How far left to how far right? Keeping an eye on the closed or the open circles. How low to how high? Once again, keeping an eye on the closed circles. Can anybody help me out? Did anyone figure out what these two were asking? Yeah.
Were they asking for what the range is when that is the domain?
Kind of. Can you help me out with what you answered then for f of -1?
I got f when f is -1, y is 1.
Maybe say that just a little bit when you know that was good. F of -1. What's this notation called? F of
Function notation.
function notation, and what's normally there? Not the -1, it's f of x. Ooh. So what's -1 representative of? X. So this says, what is the function's value? What is f when x is -1? So the way Lainey said it, I'm going to steal part of it. When x is -1, what is the y value? 1. Let me give everyone about 15 seconds. I want you to try to do f of 2. Maybe you did get f of -1, maybe you didn't. But now that you see that f of -1 is 1, 15 seconds, what would you say f of 2 is? Go ahead and write it down. Not f times 2, f of 2. function value when x is 2. Alright, shout it out. What do you think? Good. Why? When x is 2, what y goes with it? So these ones we're having you look at actual points. So I like, Lenny, the way that you said the domain and the range. I would just make it a little more specific in that it's asking for the y coordinate of the point when x is -1. You don't have to go into the domain and range. So domain and range is an interval from 2, whether it's left to right or whether it's low to high. But whenever you're given f of x, they're just asking for the y values that go along when x is whatever they put in the parentheses. Function notation, that was a review. All right, we have a couple more things we need to talk about with graphs. Nice thing is, I'd say half of them are review, like this one. We've actually already talked about zeros. We talked about it in our graphing calculator handbook. Second trace has a zero function, right? A zero operation that you guys used in your graphing calculators. And I think it was numbers 1 and 2. At least number 1 on your quiz. Finding the zero of a function. But what's another name for zero? X-intercepts. So you find the zeros of a function, you're finding the x-intercepts when y is 0. Which is why I say, in order to solve for them by hand, on a graph, we're going to look for x-intercepts. To solve them by hand, we're going to set the function or the y value equal to 0 and solve. However, solve please, please, please write what I'm writing right now. Solve the factor. Please, please, please solve the factor. And some of you are like, ugh, I didn't like it in Algebra 1, I didn't like it in Algebra 2. I'm just going to fail at it in pre-factor. We're going to review factor. But I'm actually going to do the problem in 2 steps. I do have an example. I'm going to reorder it. Just because technically this section is called Analyzing Graphs. So let's start by looking at a graph. Let me give like 2 more seconds, whatever you need from this page. I want you guys to look at the graph, and I want you just looking at the graph. If you have a graph, how do you find the zeros? Does this make sense? Now, if you're like, there's no sense to that, you can just tap on these and be like, hey, what's this 0? Hey, what's that 0? But can you do that with your TI? Bummer, no. Not that advanced. But what can you do instead? What's the operations again, really quickly? Second trace, and then is it number 2? Second trace, number 2. And then it asks you questions like to the left and to the right. Remember, you have to sandwich in the 0. Go a little left, a little right, find it. But if they're giving you a graph, aren't we just looking for where the graph hits the x-axis, right? Do we say the y-axis also? No. So the zeros would just be the x-intercepts. Those are the points. These are the x-intercept points. But what do we answer for the zeros themselves? Just the x values. Because when we call something a 0, we're saying y is 0. So we don't want to write the points. It's kind of like being redundant. So the zeros are just the x values of the points where the graph hits the axis. Now, that's if you're given a graph. What happens if all of this just disappeared? What would you be left with? The equation. So the next page, we'll give you 20 seconds to get down what you need. It's a quick reminder that the zeros are found by locating the x-intercepts. You might need to go back to your handbook to review how to do it on your calculator. But the answers are just the x's. So just -2 and 5/3. But the next page we're going to say, what if let me change this because I changed the order, sorry, we'll make that 3a. What if I just gave you the equation? We'll make him 3b. Now, you already know the answers, you just wrote them down, -2 and 5/3. If you had a graph, you could look at it and say, boom, there it is. There's one, there's the other. The two places where it hits the x-axis. And how do we solve this if we just have the equation and we don't have the graph and we can't use our calculator? It becomes 0. Not factor yet. First, plug in 0 for the, set the whole equation equal to 0. But now, Sally, the name of the game is?
Quadratic.
Got a factor. Started to do cursive and I felt bad, so I stopped. So, yeah. Some of you can read it, some of you can't. Factoring. I'm going to show you guys how I factor. It's probably very different than how you do. Then we're going to go back and review the X method with grouping, which is, I think, how most of our Algebra 2 teachers teach it. Okay? Let me show you my way first. Do you guys know how the answers to factoring look like when you're done? Not when you solve the zeros, but just the factors. What do they usually look like? They're both in parentheses. You have 2 sets of parentheses, right? And that's like you FOIL them to check it. So at the end of the day, what we're trying to get is 0 equals 2 sets of parentheses. True? Okay. If we have a normal trinomial, 3 terms, what are each of these going to be? Monomials, binomials, trinomials? Binomials. They almost always have 2 pieces with a sign in between, right? A plus or a minus. Now, this problem came from foiling this problem, right? If you FOIL this one out, combine my terms, you get that problem, true? Okay. Almost always in foiling, when you do the F or the first, don't you multiply the 2 firsts of each of the pairs of parentheses? Isn't that usually true? This one, the first and the first, almost always makes the F, which is almost always this term right here. I think, what times what can get me 3x squared? And I think, well, there's not much. It's a 3x and an x. If my factors are nice rational numbers, it's not going to be some weird decimal or fraction here. It's just going to be 3x and x. So I think about, let me tear this apart, or let me break this apart and say 3x times x, would it get you x squared? Yes or no? Sorry, 3x squared. Yeah. So I am working backwards. I'm saying, well, that's my f. What piece of this trinomial do you think comes from the L, or from the lasts being multiplied? The last come from, or the last multiplication makes this -10. Now question, what are some ways of making -10? 2 and 5 or 1 and 10. Now, we have to throw a negative in there somewhere. But for right now, 2 and 5 or 1 and 10. The only ways of getting 10 from nice rational numbers. So I'm going to go ahead and say, all right, let's just say 1 and 10. And when you get really good at it, you don't even have to write it down. You just think about it. But here's the dilemma. Where does this little middle guy come from? The outer and the inner added together. So what am I going to do down here to see if I'm right? Odds are in the first try I'm probably wrong unless I'm really good at this. And P.S. I made it wrong so that we could see how this goes. What do you do if you do the outer and the inner? What does that get? 30x and 1x. Now if you guys, I don't know if you were the ones that did this. Foiling just like a little smiley face and there's his nose. Anyway, but that's why I taught Algebra 1. But anyway, coming back. The outer and the inner, right? The outer is multiplied, the inner is multiplied. Can 30 and 1 possibly add or subtract to get 1? No. Well, that's wrong. So, what am I going to change? The 3x and the x? No, that's the only way to get that. What do I change instead? The 10 and 1. Now, pause. I'm trying to teach. Some of you already know the right answer. What if I just switched them and said 10 and 1? What am I going to check? The outer, 3x, and the inner, 10x. 3 and 10? 13 or 7. No, it's not going to work. So is 1 and 10 a good option for this problem? So what do I bet is a better one? 2 and 5. Now I did hear a negative 2 and 5. Oops, I need to get rid of 10 also. But couldn't it be 5 and 2 or 2 and 5? Let's try 2 and 5. But can you guys look real quick? Is that good? Because it'd be 15 and 2. Do you see it? 15x and 2x. Is that good? No. But is the other way good? Some of you who might like this method saw it before I got there. Why is this good? What does 2 and 3 make?
6.
And what does 5 and x make?
5.
6 minus 5 is a positive 1. Now wait. 6 minus 5. So question, where should my negative go? In front of the 5, because I need this guy to be the negative. And I need the 6 to be a positive. Now, at this point, we can double check with what you guys just wrote down from looking at the graph. How would we finish solving this problem? When you have factors equal to 0, you have to set each factor equal to 0 and solve. Now, I know some of you do this in your heads because you've done a lot of these. Most of you, by looking at this, knew that x equals negative 2 is one way. Just a few of you would have gotten stuck here. Subtract the 2 to the other side, yes. You do get the negative 2. And yes, by adding the 5 and dividing the 3, you also get the 5/3. Now the dilemma is, this was my way of factoring, and I showed it to you very slow, and I showed you all the wrong combinations first. My head, I would have written the 3x and the x, and I would have been like 10, 30 and 1, 3 and 10, 2 and 5, and I would have been like 15 and 2, 6 and 5, perfect. Answer. That's what I did. But pause. A lot of you guys need the in-between steps. So let's talk about the in-between steps. If your brain doesn't want to try that jump, what we would call the guess and check method. You see this as F and OI and L, and you break it apart and guess and check literally by doing like little baby foilings. The other way is going off to the side and asking, what are the factors of negative 30? Whoa. I didn't write negative 10, I wrote negative 30. Why? Why is this a hard factoring problem?
Because it has an A that is not 1.
Yeah, ax squared plus bx plus c. My a is not 1, it's 3. How did I get the negative 30? If you're going to do grouping, what do you have to do? Multiply the a and the c. Multiply the 3 and the negative 10. Factors of negative 30. I'm just going to leave the negatives off. We know that we need 1, right? We need a negative. How's 1 and 30 going to work with getting our 1? Awful. How's 2 and 15 going to work? Awful. How's 6 and 5 going to work? You can do it this way, or if you like, some people use an x, and they put the negative 30 here. They're trying to get the 1 for the 1x in the outer inner, and then figure out a 6 and a negative 5. We'll do it. So you can find the 6 and 5 this way, or you can find the 6 and 5 that way. I'm going to go ahead and erase this one for a second. I think most of our teachers show the x. Now, what do I do with that 6 and negative 5 once I find it? You guys remember? Break them up. O and I combined to make 1x. I need to break him up to get down to this factor. And I'm going to put a 6x and a minus 5x. I'm going to rewrite the 3x squared. And word to the wise, don't ever write a minus. Because what we're about to do is put parentheses to split it up, put a plus and negative, because as soon as we put those parentheses for grouping, remember grouping now? I need that plus in there. I don't want it to look like times, or else I'm in all sorts of trouble. This is called the grouping method. You multiply the 3 and the negative 10, negative 30. Look for factors that multiply to be 30 and add to be the inner term of 1x. Take that 1x and you split them up using the factors that you found. So I made a 6x plus a negative 5x. That does work. Now, in grouping, do you guys remember what you look for?
Things that you can factor
What's in common? What's in common for 3x squared and 6x?
out. 3x.
So pull it out. What's left? Good. Plus, what's in common between the negative 5x and the negative 10? What's left?
X and 2.
Plus 2. You can always double check. Negative 5x minus 10. How do you go from this to this? What's in common? So we pull out the x plus 2's, and what's left inside? I know there's a fly. What's left inside? Got it. How many of you guys have done grouping in the past? Why are you so quiet? What makes this one hard? There's 3 in front. Because normally you just look here and say 1 and 10 and 2 and 5, and I was able to do that because I did my 3x and x and I had to FOIL and check. But whenever you have a number in front and you're doing grouping or you're trying to go straight here, you have to realize something has to be multiplied by the 3. So we go ahead and look at factors multiplying by the 3. Then we can split up our terms, look for what's in common, and get to our final factors. Okay? Now, tomorrow we might practice another factoring problem because I know it's not the easiest for all of you. Microphone is cheaper than $100. So right now, it's the most cost-effective way to record one. Mr. Shea had one last year, but he got it from a friend and he tried to replace it this year. And very expensive. Mrs. Christensen's looking for one for me. The most important thing I need you guys to see is this one right here, left to right. How do you read a book in English? How do you read a page? From left to right, right? Hopefully. I said English, and I said Hebrew. So from left to right. Same way we look at a graph. And maybe you realize that, because if you look down here at this graph, you'd be like, oh, it's rising to the left. No. We always read them left to right. So we say it's falling, and then it's constant, and then it's rising. But the snazzy math terms for falling and rising, I know, super crazy. Who would have guessed? Increasing and decreasing. The words aren't meant to be hard. Even the idea isn't meant to be hard. What can be complicated is how to write the intervals. Because remember, interval notation, that was one of the big new things of section 1.5. Here's how they have you continue to practice interval notation while talking about characteristics of a graph. They're going to say or ask, and I mean this like the representative examples or problems you're going to see in homework. The question might go, where's the function or where's the graph decreasing? Where is it constant? Where is it increasing? They want you to answer with intervals. Now, the first thing I need to show you is whenever you're answering this question, always only use the x's. I know we talk about y's with range. I know, how low to how high. But other than that, we never use y's to describe the graph because the words describe the y's. It's falling. Oh, the y's are falling. They're going down. Or it's rising. Oh, the y's are going up. We're not talking about the y's. The words talk about the y's. The intervals need to say how left to how right is that portion of the graph. So we always use the x's to describe the graph. Whether it's zeros, whether it's increasing, decreasing, and we'll learn other characteristics as we go. So my question to you is, what interval would describe the portion of the graph where it's decreasing? What would you guys say? How left is that interval? You see it? How left? -2. And how right?
0.
Yeah. And here's one more crazy thing. If we're talking about increasing, decreasing, and constant, I only want you to use parentheses. Now hold on, wait. Parentheses mean what? Closed or open? Well, that's confusing because aren't these all closed circles? Pause. I'm not asking where points exist. I'm asking when is the function decreasing. So here's my question. At 0, is it decreasing or constant?
Constant.
At 0? Isn't it in between? It's in between the falling part and the flat part. At 0, what's going on? It's the in between. We're not going to say at 0 it's decreasing. We're not going to say at 0 it's constant. We're going to say 0 just separates, and we're going to leave parentheses. We don't want to talk about what's going on at 0. We want to talk about what's going on in between -2 and 0. Okay? I know it's kind of hard. It's kind of weird to think about. But when we're talking about characteristics, it's not where the points exist, it's when the graph is falling. So we're going to use the in-between points to show the how left and the how right, but even at -2, we don't know what was going on before. So is it rising at -2 or is it falling? Well, I don't know, it's in between, exactly. Put a parenthesis. So you might even want to make yourself a little note. With increasing or decreasing, always use parentheses on the intervals. Okay? What's going on, or I should say, we already did the how left of the constant. 0 starts it. What stops it? 2. Keep it parentheses for all of these. And increasing, when does increasing start? When does it stop? And the reason why we don't say something like infinity, guys, is there's no like open end. They closed it with the endpoint, so we stop where they stop. We say, okay, fine. That's it. So decreasing, -2 to 0. Constant, 0 to 2. Increasing, 2 to 4. Okay? So the words aren't meant to be hard. The intervals are where it gets tricky. You guys got it okay? Couple more seconds. Let's see if we can practice it. I want you guys to take these 3 graphs. Why am I spacing so weird? I'm not even going to ask you for constant. I guess I probably could. I'm just going to ask you for increasing, decreasing. The homework might ask you for constant as well. I'm just going to ask for increasing, decreasing. Let me go ahead and check it out. Left or right. And just to model something for you, I could write x as an element of x with a little e 6 times, or I could just be like, well, you guys know what I'm talking about. Let's just do the parentheses. Does that sound okay? All right, I'm going to leave off the x with a little e because I would have to write it 6 times. Can we take them one at a time, all together? Letter A, left or right. Where is it increasing? How left would you say it starts to increase? -infinity. There is no endpoint. So since there's no endpoint, I'm going to say -infinity. Go all the way as left as you possibly can and start moving right. It's going to be going up. So -infinity all the way till, yeah. Just a couple of you might get stuck at 0. Just a couple of you might get stuck at 0. The weird thing is, even though it's going up at tiny amounts, like smaller and smaller and smaller amounts, it actually keeps going up that entire time. The one exception is at 0. It's actually stopped at 0, but you need calculus to figure that out. So we're just going to say, you know what? It doesn't level out for an entire interval like this one. It doesn't level out for an interval. And according to calculus, we can say it stops at 0, but that's it. So we're going to say, you know what? As far as interval goes, it's going to always be going up. It does stop at 0, but that's not an interval. So we're not going to say it's constant. Well, I'll put constant in parentheses, I suppose. No, we'll just leave it. We're not in calculus yet. So I just get a quick little preview. Is it decreasing anywhere? No. It's not decreasing anywhere. It's not going down anywhere. What would you guys see for the next graph? Can you see it? The numbers are kind of small. Let me turn off one of the lights so you can see it a little better. Where is, let's ask the second question. Where is letter B decreasing? How far left is the decreasing portion? You guys see where it's falling? See it, right? Like a roller coaster, that's the downhill slope. Okay, how far left is that? How far right is that? Exactly. -1 to 1. Now careful, I'm not saying a point. I'm saying an interval. I'm saying -1 is how far left. +1 is how far right. Does that make sense? Don't use the 2 and -2. No. Use the x's. The x on the left and the x on the right. What would we say for increasing? Okay, I like the negative infinity because all of this is rising since forever, right? Since negative forever. When does this part stop though? -1. Remember, it starts falling. But that's not the only increasing, right? So do a comma and say, hey, there's another interval. Where else does it start increasing again? It starts at 1, and then how long is it going to be increasing for? Good. Good. How about letter C? Increasing, let's start there. Good. It's going to be from -infinity as you move left. So -infinity all the way till 0. Remember, use the x, not the y. When does it start decreasing? How far left? 2. And how far right? Well, you're moving to the right, so you have to be a positive infinity. Does that make sense? Remember line? Negative infinity is that way. Positive infinity is this way. Now, if I was to ask you, constant, what would you say? From 0 to 2. Why would you answer constant on this one as opposed to that one? Because there's an interval. There is a left and there is a right. So you would answer that as a constant if there was a third column. Does that kind of make sense? So once again, graph is going up, graph is going down. That's a basic graph is flat, right? That's kind of the basic idea, but the intervals are where it gets a little complicated. Not points, intervals. All right, cool kids. We're almost there. I think this is the last idea. Yeah. Oh, even odd. This one, oh, no. You guys don't have to do this at all. Forget that. And then, let's start here. Ignore that. A little too much fun factor. But that's okay. We have 2 more formulas. The first one is average rate. And I just want you guys to know average rate is the same thing as find the slope. So it's going to look a lot like y2 minus y1 over x2 minus x1. The problem is, what if they don't give us any y values? Problem is, what if they don't give you y values? our objective, if they don't give us y values, is to find the y values. They give us x's, they don't give us y's. They're going to give you a function. So you're going to take your x's and you're going to plug them in and find the y's yourself. Now, Kayla's listen carefully. Technically, we've covered the majority of the section, but we didn't get to, well, one more page of notes and two examples. So here's what I'm going to do. You need to fully attempt, and there might very well be a start check tonight. You're going to fully attempt everything you can at homework. The two topics, I'm going to look and see where these numbers apply or come up. Average rate and even odd. You're allowed to stop when either of those come up. Tomorrow we're going to finish average rate and even odd. We'll start the test review in class. Tomorrow night's homework will be the test review. The quiz or the test has been delayed until Friday. I'm going to see that. I'll delay the test one more day, so I'll have a day and a half of review. Test you could almost
Just ask people. Yeah. I did some science in that.
why don't you try and see, and maybe like tonight as far as hearing what values. I'll be here. Graphic acquisition.
So that's even, but it says symmetric to origin.
It's even. Hi, I'm here, so we can actually review. Does that sound good?
Yes.
Although no one emailed me about the even answers, and I didn't remember